Here, let's take a look at the 77 combinations. What is this problem is talking about? We'll be given two integers, n and a k, and return all the possible combinations of k numbers chosen from the range of 1 to 9. What does that mean? Let's take a look at the example. Like we have n4 and k2. And also k2. What does that mean? N4, it means the numbers can be choosing from 1 to 4. So it means like 1, 2, 3, 4. We have these possible candidates. And k means like how many digits for the new number. Like we only have 2 digits, right? And it means like we can have the combination like 1 2 1 3 1 4 or 2. Of course we are not 2 3. We can also go back to here. We can have 2 1 2 3 2 4 and so on. Oh no, that's not what this problem is talking about. We have 4 chosen. We only have 1 2 1 3 1 4, and then it's 2 3 2 4 and 3 4. The combination is unordered. Like 1 2 and 2 1 is the same. So we cannot do that. It means that we cannot go back to the previous one. Alright, so alright, and we can have the numbers index 1 2 3 4 here, a 0 1 2 3. And now how we construct this number, like, of course, the first thing in my mind is we definitely have to loop the numbers so that we can pick it from these numbers. Like, we definitely have to loop it, starting point. And if we are starting points here, and now the next number we can have is, for example, is 1. Let's make it bigger. 1 and 2 or 3 or 4, right? And for the 1, the next one is we can only pick from the next position, like 2 3 4. So we can have 2 3 4. And now this is the index I'm thinking from the numbers. And how about like from the level side, we only have like k2, so it means that the size of the list is, for example, here at first at starting point our size is 0, and then at this level our size is already 1, and then size is 2. So it means that in our outer loop, if the number size, alright, we can make it as the sublist size meets 2, right? We can just add the sublist to our result. And also, we can loop inside this. We can have the number 1 starting from 1. And now we need to, after we add the result, if not meet the size, we can continue to do the choosing the numbers in the what we have, like we can do the loop. And how we do that is, I'm wondering, like we can just starting the index from the next position. The next number of index. So it means that we will have a parameters like the current index, right? The current index, and for the next numbers index, we will just edit 1 starting from that one. So we will loop the numbers from the next number of index to alright, it means that it can have a starting number from a specific number index to the end, right? And now we can, what we do in this level is like we can add from this specific the current number into the sublist. For example, like we can continue as this. So let's take a look at as the second line first, not starting from the first. Assume that our process already processed starting from the number 2, and we are made this loop, and it need to find the next number to add it to this sublist, and we can find it. We have to add the number 3 here. After we for example add 2, we can continue to explore by calling this function. I mean the next number. So now we can pass the next number at the specific number index into when we are calling the function explore next position. Like for this, the next position is the number index is the sublist, the next position in the sublist, next number by calling this function. So now we continue to explore like having the number 3 here, right? When we are adding the 3, so we will go back to this function again. We found that the sublist size already met 2. We can add this sublist to result. And after we're doing this, we can just return, right? So we will come out from this calling function and do the next step. It's like what we need to do. We need to remove this number, right? And we go back to the last level. We have to remove the current number from the sublist. So after removing it, we are finish this current number. We can go to the loop to loop another number is 4. So we can go to the 4. And we can add the 4. After we add 4, we calling this function. And then also the size means 2. We can add it to our result. So it means that first we are thinking about having the loop in our numbers. Here is the having the loop. What is the part of the code is this part. Loop it. And also we have to remember is that we always try to do something, but then we also revert back. So then we can go back to last level and then start to explore the next possible candidates. And this is for the loop in the numbers. But for the outside is we have to continue to append our result is our about this size of our sublist. So for this part is our outside loop managed by the calling function. So this is the whole idea, the pseudocode I wrote. And now let's take a look at the coding part. Let's come to the coding part. And as we said, this function is this is the backtracking function, and we don't have to return anything. We can just add the result in our parameters so that we can always keep track of the new constructed sublist and also the result list. So we have a private function and no need to return anything. You can call it this way, this backtrack. What we need to have is we need to have the numbers list, right? And also the size of the sublist we want to build is k, and then we need to have our result list as well as the sublist. How we have to keep track of is the sublist. Yeah, and as we said, once the sublist meets the size we want, for example, sublist size means what we want is like k, we have to add this sublist to our result. However, we cannot just add this sublist directly, because when we are going back to the last level and we will remove some numbers from the sublist, if we are always use this variable pointer the original sublist, the original sublist definitely will be add something and remove something. It will affect the results in our result list. So it means that we have to copy this sublist to add the results into our result list. So we have to copy it using a release to copy it. And after we add the sublist into our results, just return back to make the call go back to this loop and can continue to explore the next numbers. And now let's come to the loop part. We will need to loop the numbers in the list. Oh, so here, because we are have to define a specific index when we are starting, so of course in this function we also pass a parameter is the number index, right? So our current the start from explore which number index is based on the one we pass is number index, and then you have to within the range of the current numbers list. So now we can add this number into our sublist. And start to backtrack. Now the numbers list is still the same one. K is the same. Our results is the same. The sublist is also the same. But the number index is we need to explore the next one of the current number index. So it should be I plus 1. And then after we come back from the next level, we like from the level 2 to the level 1, we have to remove the number we just added. So we have to remove remove the last number. So it will be sublist size -1. This is the index, the last index, and then we remove this number, and we can continue to explore for the next number. And now this is how we construct the sublist and add it to the result. And let's go back to the main part, like how we combine it. Like, because we have to call the backtrack, what we need to have is we have to construct this numbers list. So how we construct the number array, right? And also we need to have all this. Have the result list, new array. Yeah, also the sublist. And then we start to backtrack. We have to pass the numbers list and also the K number. And we already have the result list and sublist. And which number we start from is from 0. Submit. And then we return the result. And now let's construct the number list. The numbers are starting from 1 from 1 to n. So for example, like we can have this. This is the size of it in n. I plus 1. This is what we will get. So now we construct the numbers list. And any edge cases? Think about that. Like we here we can see n is more than 1. K is also more than 1. I believe that there's impossible that we don't have like any numbers array, or the digits is at least we will have one. So this is we how to start to construct it. So that's fun. And now let's take a look wrong. Okay, we are initialize our array, and now the test cases is passed. Looks good. We can submit it. Looks good. And now hope you can know how we have the idea first, and then based on the idea or based on the pseudocodes, we can write our Java code here, and it only took us around 8 minutes to do that. And now thanks for watching.